Yeah, so we're here for question 6 of assignment 1. And basically part A of question 6 is asking us to prove that this equation is not exact. Just like the previous equations, we're going to assume the first part is our P, and this is our Q. So the exactness test is derivative of P with respect to T is equal to derivative of Q with respect to X. So let's just do that right now. So the derivative of P with respect to T is X, while the derivative of Q with respect to X is equal to 2X. And as you can see, they're not equal, so that's basically the that's the proof that you need. So that's part A. Part B is quite simple too. It's just multiplying this equation by t should make it exact, and they want us to prove that it's exact, and then continue solving it then. So the equation would then look something like xt squared dx, and that is still our p, plus t squared plus tx squared dt equals 0. And that's our q. So now the test for exactness would be derivative of p with respect to t is equal to 2xt, and the derivative of q with respect to x is equal to 2xt. And as you can see, they're equal, so a function such as f of xt does exist, so we can continue solving this equation. So all we really need is the two main properties, which is derivative of f with respect to t is equal to q. Sorry about that, let me just write this again. Is equal to q, and derivative of f with respect to x is equal to p. Let me just write the xt's over there. So you could go either way. I'm going to first take this equation and this one and solve for a partial equation for f. So we'll get d of f over d of x is equal to xt squared. Take this to the other side and integrate both sides. So you're going to get an f is equal to the integral of xt squared d of x. This is quite simple. Since we're only integrating for x, we can take the t out, which will make it something like t squared integration of x dx, and that's a pretty simple integration where it's just going to be t squared x squared over 2. So that's plus g of t, sorry, not g prime. So that's your equation for now. What you have to do now is to continue solving for g of t. So I'm just going to rub this off. And rewrite the equation up here so we know what it is. So f is equal to t squared x squared over 2 plus g of t. And the reason we have g of t here is because we've only actually got a partial equation of f. We still have to derive for t, well, integrate for t to actually get what g of t is. But in this case, we only integrate for x. So now we're going to use the second equation, which is this one for us in this case, to solve for g of t. So if we just get that here, it's going to be the derivative of f with respect to t is equal to this equation right here. So if we derive that with respect to t, you're going to get something like x squared over 2 multiplied by 2t plus g prime of t is equal to q, which is here, t squared plus tx squared. Now if you notice, this and this are going to cancel, and you're going to be left with tx squared and tx squared here, so you can just easily cancel them both, and you're just left with a g of t, g prime of t, is equal to t squared, and you just have to integrate both sides to get your g of t. So your g of t is equal to t cubed over 3. Now plus c, sorry. all we actually need to do is sub that equation over there, and you have your f is equal to, I'm just going to do it here, f is equal to t squared x squared over 2 plus t cubed over 3. Now, plus c. Now, just like before, we know that this, since f is equal to 0, we can, well, since d of f, I'm gonna write it here actually. Since d of f is equal to 0, as we can tell from this equation, we can make the assumption that f is equal to a constant k. So so it'll just be k is equal to t squared x squared over 2 plus t cubed over 3 plus c, and the c and the k can easily get absorbed, so you can either use c or k. In this case I'm going to use c. c is equal to t squared x squared over 2 plus t cubed over 3, and that's actually your final answer for question 6.